I'm Anil Kumar. Welcome to my series on polynomials. We'll begin with very simple concept. We learned that area of a rectangle can be found by multiplying length and width, right? So let us say we have a rectangle whose sides are 3 and 8. Let us say, right? So we have a rectangle whose length is 8 and whose width is 3. In that case, area, which is equals to length times width. Now when I write dot, it means multiplication. Now in a rectangle, opposite sides are equal, right? So we have width of 3, length of 8. So we know that the area of this rectangle is 8 times 3, right? Which is equal to 24, correct? So that is how we get area of a rectangle. Now, look at this rectangle once again. We will make a small change in this rectangle by partitioning, right? So let's say we partition this rectangle. We still has the width of 5. However, I make this partition so that we have 6 on this side and 2 on the other side. So still we have 8. So it is the same rectangle with the same area of 24, right? Unit square, of course, right? We'll write unit square. If I partition, then what happens? Well, we get two areas. Area of this portion here will be what? 6 times 3, which is 18, right? And the area of the other portion will be 3 times 2, which is 6, right? So the area of the other portion will be 6. As you can see, if I add 6 with 18, what do I get? I still get 24, correct? So I get the same area. So what we have learned here is that 3 times 8 is same as 3 times 6 plus 2. Do you see that? Because 6 plus 2 is 8. And therefore, I can write 3 times 8 as 3 times x plus 2. Correct? And now, let us introduce variables, right? So let x be length of a rectangle. Right? So what I am saying is now that we change this length to some general terms, right? So we are just making it a variable. So in polynomials, we have variables into consideration, right? So if x be the length of the rectangle, so let me again draw a rectangle here. And if I write this as 3 and this side as x, in that case, what is the area of this? Well, the area is 3 times x. So instead of 8 as a number, if I put something else like x, y, or z, area will be 3 times that variable. So it becomes 3 times x. You get the concept, right? So the area is same. But now, when we introduce variables, we are talking about polynomials, right? So this is algebra. So this was arithmetic. Now we have moved to algebra, correct? Now let me take another case and we'll take another rectangle this time and we'll say, well, let it be a plus 2 and we'll keep this side as 3. In that case, as we learn, area should be 3 times a plus 2. Since this total length is a plus 2, right? A is this much and 2 is that much. And we could write this area as 3 times a, which is 3a, plus 3 times 2, which is 6. Or we could write this as 3a plus 6. Do you get that concept, right? So what I'm saying here now, the area of this portion will be 3a, right? The area of this portion will be 3a and the area of the other portion will be 3 times 2, 6. You get the idea, right? So That is what we are calling polynomials. This makes sense to you. Now, let's look into this portion carefully. We'll look into this portion carefully. So what we have here is 3 times a plus 2. What did we do? We first multiplied 3 with a and also with 2, correct? So when we did so, we get 3 times a plus 3 times 2, which is 6. This property is called distributive property. So this is called distributive property. Now it is a very useful property which we could use many times, right? So if I give you this time something like this, that if I have area as equal to 9x plus 3, then I could actually make a rectangle where I can take 3 common and have sides as 3x plus 1. That could be giving me the same area as 9x plus 3. So if I give you another question where the area is given, we are doing the reverse calculation now. So reverse. We are given the area, we need to find the rectangle. Earlier from rectangle to area, now from area to rectangle. So what we could do here is we could make a rectangle whose one side is 3, right? So let's write this side as 3. The other side is 3 times x plus 1. So that means this side is 3x and then 1 unit. Now this area is same as the expression given to us, which is a polynomial expression. Do you get the idea? So that is how multiplication in polynomials happen, correct? So this is a very important aspect which we have learned here. Now we'll have few examples for you based on this concept to explore more about polynomials and their application to represent area. This is for our middle school students who learn distributive property using area of rectangles. So based on this, we have 5 questions here. We'll answer them one by one. Let's try to understand these questions. Question number 1 is, draw a rectangle to show that the following are equivalent. That is 6 times 4 plus 5 is equal to 6 times 9 and 3 times x plus 2 and 3x plus 6. So we have introduced x, which is a variable, and therefore now this becomes an algebraic expression. The first one is without any x or unknown. So these are the numbers. It is an arithmetic expression. Question number 2, expand 5 times. So if nothing is in between, times or multiplication is applied, right? So expand 5 times 2x plus 3 using distributive property. Represent it as area of combined rectangles, right? So before moving further, what we're trying to say here is 2 things. One is that if I'm going to multiply something, let's say we have a rectangle here, right? So if in this rectangle we have one side as, let's say 3, right? The other side is, let us say 2 and 4, correct? So in that case, area of the rectangle is equal to what? Area is 3 length into width, right? So 3 times 4 plus 2, right? 4 plus 2, which is 3 times 4 plus 2 is 6, which is 18. That is one way of doing it. The other way of doing it is that you find area of each portion, right? So the area of this portion is 3 times 2, right? So we have area as equal to 3 times 2 plus 3 times 4, right? So 3 times 2 is 6 and 3 times 4 is 12, and when you add, you again get 18. So what we did was, we used our rectangle area. So this area combined with the other area gives us the total area, correct? So from here, we also see one thing, that is, if I'm going to multiply 3 by 4 plus 2, I could write this as 3 times 4 plus 3 times 2, right? That is to say, we multiplied 3 with 4 and with 2, just as we have shown here. Now this property is called distributive property. Clear? So in this exercise, we are going to use that strategy. So we are going to find area using a rectangle. We can actually combine the numbers and then multiply, or we could do it separately as combining the areas of marked regions to find the total area, and that is equivalent to using the distributive property, correct? So with that in mind, you have to answer these questions. Is that clear? All right. Okay, so question number 3 is to expand 4 times 5x plus 2y plus 1 using distributive property. So the distributive property can be applied to not only two numbers, there could be any number of numbers or expressions inside. Question 4, multiply 6 into 29 using distributive property. And there's a bonus question. The area of a rectangle is 9x plus 6. Find possible perimeter of this rectangle. 4 choices are given to you. You can actually pause the video now, answer the question, and then look into my suggestions. Now let's answer these questions one by one and understand the strategy. The very first question is, draw a rectangle to show that the following are equivalent. So first one is, for us, 6 times 4 plus 5, right? And the other one is 6 times 9. So we have to say this is equivalent to 6 times 9. We can show it with the help of a rectangle. So let's make a rectangle whose sides are 6. We'll take as the width of this rectangle, right? And 4 plus 5, which is, let's say this is 4, and the other side is 5, correct? So 4 plus 5 is actually 9. So there you can see a rectangle whose area can be found by 6 times 9, which is 54, or by adding these two areas, right? So we can add the area, which is 6 times 4 with 6 times 5. Correct? So if you add 6 times 4, which is 24, and 6 times 5, which is 30, what do you get? You get 24 plus 30, which is 54. And you know 6 times 9 is also 54, right? So from this rectangular model, we can actually show that the expression 6 times 4 plus 5 and 6 times 9 are exactly same, right? So therefore, we can say that 6 times 4 plus 5 is same as 6 times 9, right? And both are equal to 54. Perfect. So that is the way to show it. Now we'll look into the polynomial 3 times x plus 2. When there is nothing in between the number and the brackets, it means multiplication, correct? So what we have here in part B is 3 times x plus 2. We need to show that this is equal to 3x plus 6. Now again, we'll just sketch another rectangle, and now this time let us say that the width is 3, right, which is getting multiplied with the length whose sides is x plus 2. So let's say that is x plus 2, right? So this is x and this is 2. So when you multiply, you do get this area, combination of these two. So this area is how much? This area is 3 times x, and the other area is 3 times 2. Do you see that? And the side which we have actually is x plus 2, right? So that is x plus 2. So area of rectangle is indeed equals to 3 times x plus 2, which is sum of these two areas, right? So which is also equal to 3x plus 3 times 2, which is 6. So we get 3x plus 6 as the area of this rectangle. Now this property is called the distributive property, right? So this property is called distributive property. So based on this, we'll have more examples. You first multiply 3 with the term, the first term, and then the second term within the brackets, right? Now let's take question number 2, which is expand 5 times 2x plus 3 using distributive property. Represent it as area of combined rectangles. So first part is to expand. We have to multiply 5 with 2x plus 3, right? So multiplying first 5 with 2x and then with 3, what do we get? We get this as equal to 5 times 2x plus 5 times 3. 5 times 2x is 10x and 5 times 3 is 15. Now we could show this as rectangle with one side as 5, the other side as combination of 2x plus 3, right? So here we have a rectangle whose width is taken as 5, the number outside, and inside we have this length as 2x plus 3, right? And as you can very clearly see, the sum of these two areas, this is 5 times 2x and this area is 5 times 3, and their addition is 10x times 10x plus 15, correct? So that is how you do such questions. Is that clear to you, right? So these are the two areas which get combined to form you the combined rectangular area. Next question here is question number 3, where we need to expand 4 times 5x plus 2y plus 1. Now this property can be extended to any numbers, right? Now we have a trinomial inside the brackets, right? So we'll have now multiplication of 4 with 5x plus 2y plus 1. That means that multiply first 4 by 5x, then by 2y, and then by 1, correct? And add them all. So what we get this as equal to 4 times 5x plus 4 times 2y plus 4 times 1. That is 20x plus 8y plus 4. So that becomes our answer. Is that clear to you, right? So that is how this question should be done. Now let's take the fourth example. Now here is an application. We need to multiply 6 by 29 using distributive property. Now I have purposely taken this number as 29. So we are doing 6 times 29, correct? Now 29 can be written as what? 29 can be written as 30 minus 1, correct? Now that makes multiplication simpler. Now applying the distributive property, we will first multiply 30 by 6 and then 1 by 6, and we'll take away. So this is equal to 6 times 30 minus 6 times 1. Note that we could use plus or minus any operator within the brackets. That's the whole idea, right? 6 times 3 is 18 and 1 0 minus 6 times 1, which is 6. So 6 less than 180 means 174. So when you have to multiply by big numbers, which are, you don't know the times tables for 29, then this strategy helps. So that is a huge application of distributive property, which helps to simplify the question and get the results using mental mathematics. So I hope that helps. The question here is, the area of a rectangle is 9x plus 6. Find possible perimeter of this rectangle. 4 choices are given to us. How do we solve such a question? So we are given a rectangle. Just let me make one here. Now remember, for a given area, you could have different answers for perimeters, right? That's kind of important to understand. Now let us see how to solve such a question. We are given area as equal to 9x plus 6. Do you see any common factor between 9 and 6? Yes, 3 is a common factor. So we can write this as 3 times 3x plus 2. Now clearly, if you apply the distributive property, then 3 times 3 will give us 9, so we get 9x, and 3 times 2 will give us 6. So that works. It really means that if I have a rectangle whose one side is 3 and the other side is 3x plus 2, then that rectangle will represent this particular area, correct? So what I'm trying to say here is that this particular rectangle, whose sides are 3 as the width and 3x plus 2 as the length, gives me the same area as in the question, correct? So we could split this. Now, since we have done so, we know for our rectangle, we have width of 3 and length of 3x plus 2. So we need to find a possible perimeter. So what should be the perimeter? Perimeter is 2 times length plus width, right? So let's add them up and multiply by 2. So length is 3x plus 2, and we are going to add 3, the width to it. So we get 2 times 3x plus 2 plus 3 is 5. And when you multiply 2 times 3x, we get 6x plus 2 times 5 as 10. So that becomes the perimeter. And amongst the options given, C is the option which matches. Do you see that? So that is how we can correlate area of a rectangle with its perimeter even when we have polynomials given as shown here in this example. I hope that helps. The question here is, a circular rug has an interior circle of radius r surrounded by 2 circular rings of width 1 and 2 centimeter respectively. So let us say this one is width 1, that one is width 2. Write a polynomial that represents total area of the rug. Now, area of a circle basically is pi r square, right? So in our case, the radius will be this radius plus those 2 widths, right? So the net radius will be how much? So this is going to be r plus 1 plus 2, correct? So which is equal to r plus 3, right? So we'll write this as radius is going to be pi r plus 3 whole square. Is that clear to you? Right? So the radius in the formula is basically, we have to add these two, 1 plus 2. So what we get here is pi times, when you expand this, r square plus 2ab, which is 6r, plus 3 square, which is 9. So that becomes the expression for area in terms of pi. Now part B is, the interior circle of the rug has a diameter of 6 centimeters. What is the area of the rug? Leave your answer in terms of pi. So as far as part B is concerned, we are given the diameter, right? So diameter is 6. So that gives you that r should be half of 6, right? 6 by 2, which is 3. So replacing this r with 3, we will get our answer. So circle area for radius equals to 3 will be how much? We'll substitute 3 here in terms of pi. We'll do 3 square plus 6 times 3 plus 9, right? So that gives us pi times 9 plus 6 times 3 is 18 plus 9, correct? So 18 is 36 pi. Units, centimeter square. So that becomes the area when the diameter of the interior circle is given. Perfect. So I hope that helps. Application to represent area. The question here is, a picture measures 20 centimeter by 30 centimeters. Mat around the picture is x centimeters wide in the picture frame. Write a polynomial that represents the total area of the picture frame. And part B is, calculate the total area of the picture frame if the uniform width of the mat is 5 centimeters. You can always pause the video, answer the question, and then look into my suggestions. Now, here we are talking about two things. One is a big picture frame. Right? Let me just sketch one like this. Let's say this is a big picture. Now, within this picture, this is the frame of the picture. We have a picture which has uniform border, right? What does that mean? Mat around the picture is x centimeters. That means x centimeter in this side, all sides, right? X centimeters. You could write like this also. Is that clear to you? So that is the mat around the picture shown in the blue box. The size of the picture is given to us as 20 centimeters by 30 centimeters. That means this side is 20 and the other side is 30. Okay. Now we need to write a polynomial that represents the total area. That means length into width, right? So what is the area of rectangle? Length times width, correct? Now in this case, the length will be how much? Length, let's say this side will be the length. We have 30 plus x, right? So that means 2x. So this could be written as 30 plus 2x. Clear? Since the mat of x is on both the sides, as far as the width is concerned, it is 20 plus x, which is 20 plus 2x. That is important to understand, correct? And now we can write that the area will be equal to 30 plus 2x times 20 plus 2x. Is that clear to you? So part A, write a polynomial that represents the total area of the picture frame. That is this polynomial. Now this is in factored form. You could expand, simplify and write it in a polynomial form also. Let's do that. So if I multiply 30 by 20, I get 600. So let me do it in steps. So we have 30 times 20 plus 30 times 2x plus 20 times 2x plus 2x times 2x. Let me write 2x whole square, right? So which is 600 plus 60x plus 40x plus 4x square, right? So combining like terms, we can write area as 4x square plus 100x plus 600. Unit square. The unit in this case is centimeters. So the area expression could be written in standard form. This is called the standard form of the polynomial, or in the factored form. So that is our part A. Part B. Calculate the total area of the picture frame with the width as 5 centimeters. So now we can write 5 centimeters for x and calculate, right? So let's figure this out. Part B, is if x equals to 5, in that case area will be 4 times 5 square plus 100 times 5 plus 600. Clear? So 4 times 5 square, 25 times 4 is 100, right? Plus 500 plus 600. See, 5 square is 25 times 4 is 100, 500. 600, 600, 1200 centimeter square becomes our answer. Is that clear? So that is how we could actually solve this particular question. We'll have similar questions in our playlist, so I'd like you to go through the playlist and understand how to use polynomials to represent the given situation. I hope that helps. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching.